Hello students, welcome to the next lecture of the engineering chemistry course. As we are continuing the unit 4 topic lubricant, in the last lecture we have completed the classification of lubricants, in which we have completed the semi-solid lubricant and the detailed discussion about the solid lubricants. Today we are going to start the new topic, that is types, theories or the mechanism of lubrication. In this topic we will cover the three types of theories for the lubrication, that is thick film lubrication, thin film lubrication and the extreme pressure lubrication. So let us begin with the types, theories or the mechanism of the lubrication. All these three things are the same. We can say it the types of lubrication or the theories of the lubrication or the mechanism of the lubrication. Okay, basically the mechanism of lubrication means how a lubricant reduces the frictional resistance between the two moving metallic surfaces. Lubrication mechanism means it is the process by which any lubricant minimizes the frictional resistance. So, the process of minimizing the frictional resistance by introducing the lubricants between two metallic surfaces is called the lubrication. And this reduction in the frictional resistance may be of the three types. First is the thick film lubrication, which is also called the fluid film lubrication or the hydrodynamic lubrication. Second is the thin film lubrication, which is also known as the boundary lubrication. And third one is the extreme pressure lubrication. So let us discuss one by one each. First is the thick film or the fluid film or the hydrodynamic lubrication. In such type of lubrication, the lubricant is used in sufficient quantity so that the lubricated surfaces are separated completely. In such case, the lubricant forms a thick layer around 1000 angstrom thick layer between the two metallic surfaces. Now question comes that in which conditions this type of mechanism actually taking place. So this type of lubrication taking place when the applied load on machine is not too high. That means pressure between two metallic surfaces is low. Second condition is generally it is applied when one of the rubbing surfaces is slightly displaced in the relation with respect to the each other. That means movement is slow. If the movement is slow, that means the heat energy generated by the movement is also very low. Hence, the temperature between two metallic surfaces is also low. So, basically this type of lubrication can be carried out in low pressure and low temperature conditions. So, the conditions are the low temperature and low pressure conditions. Third one, generally this type of mechanism is suitable for the delicate instruments like watches, clock, gun, scientific instruments, sewing machine, etc. So the machinery parts where the movement is slow and the heavy load is not applied on between the two metallic surfaces. So in such conditions, the low temperature and pressure develops between the two metallic surfaces, and in such condition a thick layer of the lubricant may be incorporate between the two metallic surfaces. Generally 1000 angstrom thick layer is introduced between two moving surfaces. That is why it is called the thick film lubrication. For any type of lubrication, there is the term friction coefficient is used. Basically, the friction coefficient is the ratio of the force required to cause motion and the applied load. So, if the friction coefficient is low, that means lubrication is better. So in this type of lubrication, since the lubricant layer is very thick, so it totally avoids the direct contact between two metallic surfaces. Hence, in such condition, the friction coefficient value is very low. It is in the range of 0.001 to 0.003. So it is very low. So lubrication is very proper. Now, what is the mechanism of the thick film or the hydrodynamic or the fluid film lubrication? First of all, when we applied the lubricant between two moving metallic surfaces, the thick film covers all the irregularities of both the metal surfaces. As in our previous class, we have discussed that metal surfaces actually are this type of rough metallic surfaces. So first of all, when we applied the thick film lubrication, then the work of the lubricant is to fill up all the irregularities. So it covers all the irregularities between two metallic surfaces and forms the thick layer between two metallic surfaces. And due to this thick layer of lubricant, direct contact between two metallic surface is totally avoided. So no a single point is there at which the two metallic surfaces comes in the direct contact. So in such case, the friction coefficient value is very low, in the range of 0.001 to 0.003. And in such conditions, the resistance to motion is only due to the internal resistance between the particles of the lubricant itself, because metal surfaces are not touching each other. That is why the resistance developed for the motion is only due to the internal resistance of the lubricant molecules itself. Generally, the hydrocarbon oils are the most suitable lubricants for the thick film lubrication. So what we have discussed till now, that thick film lubrication is applied when temperature and pressure conditions are low, speed of the machine is low, and the heavy load is not applied onto the machinery part. That is why low temperature and pressure conditions are there. In such conditions, a thick layer of lubricant is formed between two moving metallic surfaces. Hence, in such condition, the value of the friction coefficient is very low and the proper lubrication may takes place. So this is the example of the thick film lubrication. The best example for illustrating the hydrodynamic lubrication is the shaft bearing. Basically, as we discussed, that the hydrocarbon oils are the most suitable lubricants for the thick film lubrication. So this is the shaft bearing example, in which this part is the shaft which is moving or rotating in the bearing. This is the bearing lining. Okay, so first this condition is the rest condition. This is the rest condition. In the rest position, the shaft rests on the bottom of the bearing. Now, when shaft starts rotating, second condition, when shaft starts rotating, it begins to climb up one side of the bearing as its pumping action drawn oil under it. As we start the machinery, the hydrocarbon oil, that is the lubricant, is also supplied. So due to the pressure of this hydrocarbon oil, this shaft now climbs up and start rotation. Okay, now the pressure of the lubricating oil is forced to shaft to climb up between the climb up at the center point. Therefore, there is the formation of the thick layer of lubricant between the shaft and bearing took place. As more and more lubricant is drawn, the pressure exerted by the lubricant onto the shaft, the pressure exerted by the lubricant onto the shaft. Okay, now this due to this pressure, the bearing, all the bearing part is properly lubricated, and this pressure, due to this pressure, there is a thick layer formation is formed between the shaft and bearing, and there is no point where these two metallic surfaces are in contact to each other, hence the friction is minimized and shaft moves at its maximum speed. Only why? Because there is no contact point, direct contact point between the two metallic surfaces. So now shaft is moving at its maximum speed due to the minimization of the friction resistance, and this could happen only due to the formation of thick film of the lubricant between shaft and bearing. So this is the best example of the hydrodynamic lubrication or the thick film lubrication. Now coming towards the second type of lubrication, that is thin film lubrication, which is also called the boundary lubrication. This type of lubrication occurs under the conditions when shaft is moving at slow speed. Slow speed, that means temperature generated between two metallic surfaces is low. Second condition, when heavy load is applied between metallic surfaces, that means pressure conditions are such that pressure is high between two metallic surfaces. And third condition, when the viscosity of the lubricating oil is too low. In such condition, only a monolayer of lubricant is formed onto the metal surface. Therefore, only thin film can be formed between the two metallic surfaces. Hence, the lubrication is called the thin film lubrication or the boundary lubrication, because only the monolayer is formed onto the metal surface. Therefore, it is also called the boundary lubrication. We know that due to the heavy load and the low viscosity of the oil, only a thin film of lubricant can exist between the two metallic surfaces, because already pressure is high due to the heavy load and viscosity of the lubricant is low. So there is the possibility of formation of the monolayer only. In such condition, thick film of lubricant cannot persist between the two metallic surfaces. So lubrication is the thin film or the boundary lubrication in such type of conditions. Now look at the structure here, in which, as we discussed earlier, that metallic surfaces are this type, irregular metallic surfaces. So in such condition, what happens? In such conditions, since a lubricant forms only monolayer, so some points are uncovered, still uncovered with the lubricant. So 100% direct contact cannot be avoided in such conditions, because the lubricant cannot fill all the irregularities of the metal surfaces. So at some points it may possible that both the metal surfaces comes into the direct contact. Therefore, in such condition, the value of the friction coefficient lies between 0.50 to 0.15. Compare it with the thick film lubrication, where the friction coefficient value is 0.001 to 0.003. But in this condition, the value of the friction coefficient is comparatively higher, because 100% direct contact cannot be avoided in such cases. Clear? So, what mechanism it follows? In such type of lubrication, a thin layer of lubricant is adsorbed by physical or the chemical bonds onto the metallic surface. That means there is the chemical or the physical interaction between the lubricant molecule and the metal atoms. Now the friction coefficient value is in the range of 0.5 to 0.15. Generally, a monolayer of lubricant is formed of lubricant in between the metal surfaces. In such conditions, the factors on which this type of lubrication depends are: first, the nature of the metal surface on which the lubricant layer is adsorbed, because as we said, the lubricant molecules are physically or chemically adsorbed onto the metal surface. That means the factor, that chemical affinity between the metal and the lubricant, must affect this type of adsorption process. Therefore, the factors on which the thin film lubrication depends is including the nature of the metallic surfaces. Second factor is the load applied on the machinery. If the very high load is applied onto the metallic surfaces, then pressure, due to this high pressure, these metallic surfaces comes closer to each other and formation of the multiple layer cannot be takes place. Third condition is the oiliness of the lubricant. That means sticking nature of the lubricant onto the metallic surfaces. So these are the factors on which the thin film lubrication depends. Since in such conditions where pressure is high, so in such high pressure and low temperature condition, only thin film can be formed on between the metallic surfaces. So in such condition, for better lubrication, the chemical structure of lubricant should include: first, active atoms or groups which can form chemical bonds with the metal, because in such condition it is necessary that metals on the lubricant molecule must form a permanent lubricant layer onto the metal surface. This can be takes place if the lubricant molecule contains active atoms or the groups, because these atoms or groups may form the chemical bond with the metal surfaces and a stable lubricant layer may form. Second, long hydrocarbon chain lubricant must possesses, because when the lubricant molecule having the long hydrocarbon chain, so there is very less possibility that due to the high pressure the detachment of the lubricant layer with the metal surface takes place. Third is the sticking nature of the lubricant should be high. It must possesses the good oiliness to form the stable lubricant layer onto the metal surface. Next is the lubricant may contain the polar groups which promote wetting and spreading over the metallic surfaces at high pressure conditions also. Next one is the high viscosity index. That means the variation of the viscosity of the lubricant with temperature is not so much, so its viscosity index should be high. For example, these solid lubricants like molybdenum sulfide, graphite, these are the best boundary lubricants. Now, third type of lubrication is the extreme pressure lubrication. This type of lubrication is done under following condition. First, when heavy load is applied, that means pressure conditions between two metallic surfaces is high. Speed of the machine high. If speed of the machine high, that means due to the motion there will be the large amount of heat energy generated. So temperature between two metallic surfaces is also very high. So this type of conditions are high pressure and temperature conditions. Now, in such condition, that means such a high pressure and temperature conditions develops at the surface. Hence, the lubricating oil fails to stick to the surface and may also decompose. So this is the very serious problem. Why? Because due to this high pressure and temperature condition, decomposition of the lubrication if takes place, then stability of the lubricant molecules onto the metal surface does not occur and proper lubrication may not take place. So, to overcome these difficulties, extreme pressure additives are added to lubricating oil to improve lubrication properties. The extreme pressure additives are organic compounds containing sulfur, chlorine, lead, and phosphorus, etc. So, basically, the extreme pressure lubrication is done in high temperature and pressure conditions, but in such condition we must have to add the extreme pressure additive to the lubricant. These extreme pressure additives are the organic compounds that containing sulfur, chlorine, lead or the phosphorus. Basically, these organic compounds form high melting lubricant films onto the metal surface. That means due to these type of extreme pressure additives, these additives forms the chemical bonds with the metallic atoms. Now, due to this chemical bond formation, stable compound layer is formed onto the metal surface, and the nature of these stable compound is such that their melting point is very high. That means at the high temperature they also they are very stable also. So these organic compounds form high melting lubricant films onto the metal surface, which also increase its pressure bearing capacity. So the reason why the extreme pressure additive increases the high pressure and temperature bearing capacity of the lubricant, the reason is that because these additives form the stable compounds onto the metal surface, and these stable compounds are very high melting point compounds, so they are quite stable at high temperature and pressure conditions. Therefore they form the stable lubricant layer onto the metal surface. The examples of the extreme pressure additives are the compounds which contains oxygens such as the fatty acids, esters, ketones, etc. The organic chlorine compounds like chlorinated esters. The compounds which contain sulfur, example sulfurized olefins, sulfurized fats, etc. The organic compounds containing trivalent and the pentavalent phosphorus. The organic compound containing lead. So basically the organic compound which contains oxygen, which contains chlorine, which contains sulfur, which contains phosphorus and which contains lead may act as the extreme pressure additive for the lubrication. So in all, what we have discussed in today's class, we have discussed various types of the lubrication. We may call the types of lubrication as the theories of lubrication or the mechanism of the lubrication. Mainly three types of the lubrication are there. Thick film lubrication, which is also called fluid film or the hydrodynamic lubrication. Thin film lubrication, which is also called as the boundary lubrication. And third one is the extreme pressure lubrications. We have discussed the conditions in which these type of lubrication taking place and the mechanism of all the three types of the lubrication mechanisms. Now, time for the today's learning check. In the following conditions, which type of lubrication may take place? When temperature is low, pressure is high, and viscosity of the lubricant is also low. So in such type of condition, which type of lubrication process may occur? Think for the answer of this question. We will discuss the answer of this question in our tomorrow's live class. So till then, take good care of yourself and keep enjoy e-learning at home. Thank you.